In this video, I want to take a little bit of time looking at the process of writing an algorithm. What are some of the steps that you need to take in order to develop a good algorithm, and some of the things to look out for. The first step to developing any algorithm is a solid understanding of the problem. So in order to understand the problem, we want to consider a couple questions. The first question we want to consider is, what is the desired outcome? What does the result look like? What does the solution look like? So let's take, for a working example for the rest of this video, a car. So imagine you keep seeing these new dents created in your vehicle. So what is the desired outcome of this problem if you were to develop a solution to it? It's no more new dents in your car. But in order to actually create something, a solution to solve this problem and to get this desired outcome, we need to know what the actual cause of the problem is. So is it shopping carts that are hitting my car? Is it someone maliciously attacking my car? Is it golf balls or maybe hail damage? We have to figure out what the root cause is. Now, one thing that can help us figure out the root cause is seeing if there's any preconditions. So maybe I only see new damage when there's bad weather. Maybe I only see new damage when I go to the grocery store. So it gives us a hint of where maybe the problem is occurring. We also need to consider what assumptions are reasonable to make. So maybe I'm going to assume there is no malicious intent in these dents, and that might rule out that there's someone out there doing it. But if I can't rule out that there is no malicious intent, then that's going to drastically change the solution that I create. All of these questions together, when we're trying to understand the problem, help us break it down and understand it from all different angles. And that will allow us to naturally identify solutions that we can then implement and test and hopefully ultimately come up with a good algorithm. Now that we've taken our time and done our due diligence in understanding the problem, the inputs, the outputs, any of the different assumptions that we can make or can't make, we can now start developing our solution. One of the things that we might want to do before we go too far down that rabbit hole is break down the problem into smaller algorithms and then put those algorithms together to solve the larger problem. So some problems might only need one algorithm. You can do it in one go and you're ready to solve the problem. However, some problems are quite complex and there's a lot of moving pieces, and it might help for us to break it up into smaller parts, solve the individual parts, and then stitch it all back together. So take your time with this step, because the other thing that it will allow you to do is it will start giving you a chance to understand, did I make a misstep? Did I add an assumption that was too restrictive? Or did I change the inputs in a way that modified the problem I was actually solving? So this step here is kind of reevaluating what you just did, but also kind of giving you a higher level game plan of how you're going to tackle developing these algorithms. Now that we understand what the problem is that we're trying to solve, we know what assumptions we can make, inputs, outputs, we understand the scope of the problem that we're trying to solve, we broke down into smaller pieces. What are some of the key points we want to remember when writing out algorithms? Well, the first is never assume that the implementer, even if it's you implementing the algorithm, is going to understand what you meant. You need to be clear and explicit about every single step. Now, a lot of this I've reiterated over a course of a couple videos, and I'm doing that on purpose because these are somewhat subtle for a novice programmer or a novice computer scientist, but they are very important and they will go a long way in making your skills better. The next thing you need to remember is double check everything that you do. It's really easy to skip a step, but because of the problem, you're so immersed into it, it's easy not to see that you skipped a step. So make sure you double everything with a very critical eye. This includes the understanding, all of your inputs, any assumptions, the steps that you wrote out. You need to double check everything. You need to be a stickler for accuracy and all the subtleties within the problem. Don't assume that the implementer will figure it out. That's not their job. Their job is to take the plan, the blueprints that you generated, and implement that in a particular language on a particular system. Now, the biggest piece of advice that I can give any computer scientist, especially younger ones, don't fear being wrong. This is not something that you sit down, you read the problem description, and you just write out the perfect algorithm. It might take days, it might take weeks to develop the perfect algorithm. It'll take a lot of different revisions. Just like in English class when you were writing an essay, you didn't sit down and write out the perfect essay the first time. You had to revise it, you had to go back, move things around, reevaluate what point you were trying to make, and make adjustments. So don't be afraid to delete things that you've already done and redo them. Developing your algorithm skills is going to take a lot of time, a lot of practice, and a lot of patience. You will have good days where it seems like you got everything under control, you're figuring out all the different assumptions, and the steps are just coming to you. And then there's going to be other days that you feel lost. And that's okay. When you feel lost when trying to develop an algorithm, reach out for help. Talk to your classmates. Sometimes just going through the problem saying, here's what I'm trying to do, here's where I'm having troubles, will identify, oh, maybe that's how I can fix it. And even if you don't identify it, it's most likely that your classmate or your colleague that you're talking to will say, wait a second, you skipped a step here. I don't know how you got from here to here. And that might be enough to lead you in the right direction. So work on these often. Don't be afraid of failure because you will fail. Just use that time to analyze why you failed, what you did wrong, and how you can improve. And before too long, your skills will look much different than they do right now.